Here presenting on my machine learning project report. This is my second time recording it because I'm not fitting in 5 minutes, so I'll try to move through the thing faster. All right, so the task was to predict the net hourly electrical energy output, PE, of a combined cycle power plant using hourly environmental variables. Because PE is a continuous variable, it is a regression problem. So I chose Excel to work with, as that's the one that I understand and it's accessible to me. And the two common metrics that I'm going to choose are RMSE and MAE, which reliably stands for root mean squared error and mean absolute error. First of all, it reports in the same unit, so it's easy to compare, and the MAE is going to help us to measure the average absolute prediction error. All right, so here's our variables: AT, V, AP, RH, PE. That's our target variable, right? And so I'm choosing linear regression as my algorithm, and I would like to choose the forest, random forest, as a second algorithm to compare, but it's complicated to do it in Excel. So I'm gonna use the approach of adding additional features, such as square root of AT and square root of V. That will allow me to have a second model being a linear regression model with curvature terms added to the 4 raw features to capture non-linear relationships and see if that's going to improve the model or not. All right, so then I manually split the data in a training set of 70% validation set and test set, and I run my model A with the 4 original features. Got my numbers here. Once again, the R squared is a goodness of fit, which shows us it's a pretty good fit of 93%. Then I did the same with the model B, as I said, with the squared square roots of the 2 parameters to capture that curvature, right? And so the predicted PE, even though it was calculated here, I did it in the formula taking my fixed validation set, right? All right, so then I ran the validation set on my model A, did the same with the model B, and let me quickly take you through those numbers, right? So the training sets shows 4.49 of megawatts in RMSE and 3.59 in MAE, which are higher numbers than in my model B, right? So then the validation improved those numbers and once again showed that my model B has a lower MAE, which means, it performs, my model B performs better, and that was the selected model to run the test, right? So on the test set, model B achieved RMSE of 4.32, MAE of 3.43, and that means that our predictions are typically within about 3-4 megawatts of the actual output. So considering the output range of 420 to 496 megawatts, that corresponds to less than 1% relative error, demonstrating strong predictive performance. So model B improves over model A, shows that adding curvature was worthwhile, right? And our predictions are practically useful just because we're showing a less than 1% of relative error. Yeah, I think that sums up making my predictions highly accurate and proving that thoughtful engineering can substantially improve